All right, as I promised earlier in this chapter, we will be working with systems of equations in 3 variables. How exciting! You got lots of practice in 2 variables. Now we get to do it in 3 variables. We will be constructing viable arguments and critiquing the reasoning of others. So you've solved linear equations with 2 variables. Now we're going to solve systems of linear equations in 3 variables, and we're going to solve real-world problems using systems of linear equations in 3 variables. One new word, ordered triple. This is something that I copied from the textbook because I thought it was really important for you to be able to see this. Just like systems of equations in 2 variables, systems in 3 variables have one solution. They can have or an infinite solution or no solution. A solution of such a system is called an ordered triple. Notice X, Y, Z. If it has one solution, that means that all 3 planes intersect at one point. If it has infinitely many solutions, then all 3 planes intersect in a line. And then if there's no solution, that means that there's not any solution that fits all 3 of the planes. So let's look at a system with one solution. So we're going to begin solving it similarly to what we did when we used 2 solutions. First of all, we're going to pick one variable to eliminate for all 3 equations. We're going to use elimination to make a system of 2 equations in 2 variables. So here's the first equation. Fx plus 3y plus 2z is equal to 2. Now we're going to take this second equation and we're going to multiply it by 2. We do that because we notice that this plus and minus on this z, we can get rid of the z. That's going to leave us with 9x plus 5y is equal to 12. So because we've eliminated the z on the first 2 equations, we're going to have to do something to eliminate the z on the second or the third equation. It doesn't matter if you pick the first or the second equation to go with the third equation, whichever's easier, whichever makes the elimination of the z easier. What we're going to do is just subtract these from each other. So we have 4x minus y is equal to negative 14. So the z terms in each equation have been eliminated. The result is 2 equations with the same 2 variables, x and y. So now we're going to take those 2 new systems and we're going to solve them just like we did in section 1. We're going to have to multiply this new equation that's got the x and y, this system, multiply it by 5 so that we can have the y values eliminated. So we find out that x is equal to negative 2. Now we're going to substitute negative 2 in for x in either one of the 2 equations that have the 2 variables. So here they've chosen 4x minus y. They're substituting in a negative 2, and we find that y is equal to 6. So now we have x is negative 2 and y is equal to 6. So we're going to go back in to solve for z. We're going to go into one of the original equations. We're going to put in the negative 2 for x, the 6 for y, so that we can solve for z. Z is equal to negative 3. So we write it in the format, the ordered triple, x, y, z. Negative 2, 6, negative 3. Now you can check this solution in the other 2 original equations. You need to check it in all 3 equations because a lot of times a solution will work with 2 of the equations but not the third one. Okay, time to check your progress. So pause the video and work this one out. Pick a variable that you're going to eliminate in all 3. And once you get that done, then you can solve it just like we did in section 3.1. For your ordered triple, did you get negative 1, 2, negative 4? If so, excellent. If you didn't quite get there, it could be just simple mathematical errors is what's probably happened. So you can go in and try to rework that now that you know which direction you're going. Now we're going to solve systems of equations in 3 variables if they happen to have no solution or an infinite solutions. So you're going to work them just the way you did that first one, but our solutions are going to look a little different. So we're going to eliminate y in the first and the third. Okay, in order to do that, we're going to multiply the first one by 3 and the second one by a negative. We're going to subtract it from each other. Wow, we get 0 equals 0. Is 0 ever equal to 0? Well, only all the time. So the equation 0 equals 0 is always true. This indicates that the first and third equations represent the same plane. So let's check to see if the plane intersects the second plane. We're going to multiply it by 6. We're going to subtract the third one from it. We end up with 9y minus 15z equals 27. The greatest common factor is 3. The planes intersect and align, so there is an infinite number of solutions. Now let's check this one out. We're going to eliminate x in the first two equations, so we're going to multiply the first one by 2. Subtract the second one from it. Z is equal to negative 3. Is z ever equal to negative 3? Never true. So there is no solution of this system. Time to check your progress. Here's check your progress A. So pause the video, read through it, see if you get a solution or not for this one. So they intersect and align. You get an infinite number of solutions. Very good. Let's try this one. So pause the video and work it and then check to see your answer. There is no solution to this system of equations. Very good. Now we're going to write and solve a system of equations using a real-world example. So you want to note the keywords. We're going to make a plan, solve the system, and then we're going to go back and check our answer. So the variables we're going to use is U for the number of seats in the upper level, M for middle level, B for bottom level. Our plan, there are 49,000 seats, so we add them together. Upper, middle, and bottom gives us 49,000 seats. When all seats are sold, the revenue, oh, that's nice. Seats cost 25, 30, and 35. The number of seats in the middle and bottom levels together equal the number of seats in the upper level. So M plus B equals U. So now we're going to substitute, since U is equal to M plus B, we're going to substitute it into the first two equations and simplify. Now we'll solve the system of two equations and two variables. B is equal to 14,400. So we'll substitute that in for B in one of the equations with two variables. So we can solve for M. Now we have M and B, so go into the original equation to find out what U is, the upper level. Has to be 24,500 in the upper level, 10,100 in middle, and 14,400 on the bottom level seats. Very good. Now check to see if all the criteria are met. The number of seats in the middle and bottom levels equals the number of seats in the upper level. When all the seats are sold, the revenue is 1,419,500. So we do the math. Okay, time to check your progress. These are smaller numbers, so you'll want to pause the video so you can work this out and then come back and check your answer. How'd you do? Did you get 10 pens, 7 pencils, and 8 packs of paper? Very good. You are ready to begin the exercises. Job well done.